So now we're working on multiplying complex numbers, and these look almost like the ones above, but there is no sign between those two binomials, so that is multiplication. So anytime we're multiplying a binomial by a binomial, we are doing the distributive property twice. So here I'm distributing 3 times 7 is 21, 3 times 2i is 6i, 5i times 7 is 35i, and then 5i times 2i, this is where things get a little interesting, is 10i squared. And we know from the last lesson, we can't ever have exponents on I because it actually simplifies to one of those four steps. Now, yesterday we had all sorts of powers of I. The main one that shows up in these type of problems is I squared, which we know is -1. Okay? And that is something you definitely should get used to recognizing. If I see I squared, I'm going to make it -1. So you can actually cross out the I squared and write -1 there. So simplifying, I have 21, these two combined, so I have 41i, and then 10 times -1 is -10. So here I can combine the 21 and the -10, so I get 11 plus 41i. And if we are leaving these in that complex number a plus bi form, we do always want to have the 41i second, whereas if we were writing it with an x, it would probably be like 41x plus 11. But this is the correct form now. So you can actually pause and try these two. They're pretty simple, and then maybe come back and check. So I'll start to go through them. -6 plus 4i plus 18i minus 12i squared. So this I squared, once again, is going to become a -1. So I have -6 plus 22i, -12 plus or times -1. Make sure you multiply those two. Is 12. So -6 plus 12 is 6 plus 22i. And lastly, we have -20 minus 12i minus 5i minus 3i squared. So I'm going to do this one a little shorter. If I know this is a -1 here, I could actually also cross this out and make it a +3, or you can do that in your head. So you can kind of skip a step if you want to. So -20 plus 3 is -17, your negative sign, minus 17i from these two. Okay. Now I'm actually going to skip to the next page because on Delta Math, these last couple of questions go well with, go well with what we're doing. So I'm going to skip down to exercise 4. Hello, there we go. So here's exercise 4. Now, these are still complex numbers with multiplying. I see that squared there, and we see subtraction, so I need to write this one twice. Okay. So 5 times 5 is 25, -30i, -30i, and then plus 36i squared. So on this one, we have that positive 36i squared from these two. We know that since this is -1, that's actually going to become a -36 here. So 25 minus 36 is -11, and -30i minus 30 more I is 60, -60i. So that's my answer to that. Now, the next one, something interesting happens. So we'll multiply it out first. We have 25 minus 10i plus 10i minus 4i squared. So what's interesting is these middle two terms, and this has to do with the fact that that looks like factors from difference of perfect squares. They're actually called conjugates when they're set up that way, with the middle term being positive or negative, but basically the same binomial. And these are called complex conjugates. So whenever that happens, those imaginary numbers in the middle actually cancel. This one becomes a -1, right? So I end up with 25 plus 4, and more importantly, I end up with a real number, Okay, so when you have those complex conjugates and you multiply, their solution will be a real number. So unfortunately, I probably should have picked a different problem, but this ends up being the same setup and the same numbers as the one above. It says, which of the following products would be a purely real number? So that is choice 3, and we just saw that above. But anytime I have it, so if I have 10 minus 7i times 10 plus 7i, I know that those middle terms are going to cancel. The I squared will become a -1, and that answer will actually be a real number. Number 4 is close, okay? But if I multiply this one out, those two imaginary terms would both be positive. They would get added together. They wouldn't cancel each other out.